Hi friends, welcome to the Unit 1, Day 4 notes. This is over complex numbers. At this point, we're just jumping into the simplifying complex numbers. This is going to feel a little bit easier compared to what we just did, just because the idea or the concept behind it, not necessarily difficult, is for most students just kind of a little bit easier to grasp. We've already talked about this up here. I is equal to the square root of negative 1. I squared is equal to negative 1. I cubed is equal to opposite I, and then I to the fourth is equal to 1. We can extend that. As I mentioned earlier, it's kind of cyclical. I to the fifth, I to the sixth, I to the seventh. If you think about I to the eighth is really I to the fourth times 2. Or another way that I could write that is just like I to the fourth squared. And using our properties, we know that, well, I to the fourth is really 1. So 1 squared is just 1. So this is cyclical. It's like I keep on going in a cycle on this. What I really care about is, looking at the number that I'm raising I to. If I divide that in by 4, what's left over? If I have just 1 left over, then it's going to be I. If I have 2 left over, then it's going to be negative 1. If I have 3 left over, then it's going to be negative 1. And if I don't have anything left over, then I have 1. Another way of thinking about this is if I divide it by 4, what's my decimal? Do I get 0.25, 0.5, 0.75, or no decimal at all? So if I think about this again in terms of I to the 15th, I'm going to have I to the 4th, and I'm going to raise that 3 times. That gives me I to the 12th. So I'm going to have 3 I cubed left over. So that's going to be negative I. I to the 81st power, 4 goes into 81 20 times with 1 left over. So this is just going to be equal to I. 21, I to the 122nd. That's going to... I to the 4th is going to go into that, 120 times evenly. So I'm going to have I squared left over. So that's going to be equal to negative 1. I to the 23rd, 20 times with 3 left over. So that's going to be equal to negative I. And then I to the 242. So let's see, that's going to be, I don't feel 100% confident with this. I want to say 240, but I'm not feeling it. So me being totally prepared and definitely grabbed my calculator before I started this video and not running over to my laptop bag to grab it right now. Fun fact, always make sure you're prepared before you start recording. So let's see, if I do 242 divided by 4, I should have gone with my first inclination. So that's going to be I squared or just negative 1. And then 133 divided by 4, so that's going to be equal to just I. So that's a simple way to easy way to simplify complex numbers when you have just the imaginary part. And then this last part, we're using substitution to determine if the value shown is the solution of the given equation. So remember, when you plug in a number, you plug it in wherever you see that. So if I plug in negative 7i wherever I see this x squared, I'm going to have negative 7i in parentheses, and then squared, and then plus 49 equals 0. Remember, you're squaring each of these terms here. Negative 7 squared is going to be a 49, and then I'm going to have I squared plus 49 equals 0. And remember, I squared is negative 1, so this becomes a negative 49 plus 49, and that does in fact equal 0. So by getting 0 equals 0, it is a value. So yes, x equals negative 7i is a solution. So this is a true statement. And then for the second one here, for 26, we're going to plug in that 2 plus I square root of 5, wherever we see an x squared. Or sorry, wherever we see an x, 2 plus I root 5 squared minus 4 times parentheses 2 plus I root 5, and then plus 9. When you square this, be careful. A lot of students just square each term individually. Remember, this is a binomial, so you need to do each part squared and then the middle term. So that's going to become 4 plus 2i root 5 plus another 2i root 5. You can do the table method to verify that this is in fact true. And then I'm going to have I squared 5. So that's going to be 5I squared. I'm going to continue simplifying this later, but I'm going to finish out the rest. Again, going through distributing this. That's going to be negative 8 minus 4I root 5 plus 9. Oh, forgot to bring down the equal 0. My apologies. And then now if I combine these two together, so I'm going to have 4 plus, let's see, that's going to be 4I root 5. Let's see, plus 5I squared, so it's going to be minus 5 minus 8 minus 4I root 5 plus 9 equals 0. So I'm just going to kind of condense these things together so they're by each other. So 4, so if I take 4 minus 5, that's negative 1, negative, and then minus 8, that's negative 9, plus 9, that equals 0, so those all cancel out. And then 4I root 5 minus 4I root 5 also cancels out, so I just end up with 0 does in fact equal 0, so this is a true statement. So yes, x equals 2 plus I root 5 is a solution. So if we got something besides 0 on these values, 0 equals 0, or if it's set up so that it was equal to a different number in the beginning, then we know that it's not a solution, and so then we would say false or no, x equals whatever is not a solution. Thanks for joining me on these notes. I hope you have a fantastic day. Bye!